two instruments are used to measure the height of a tower. The error made by the less accurate one is normal with mean 0 and standard deviation 0.0056h. Error made by the more accurate one is normal with mean 0, standard deviation 0.0044h. The errors are independent of each other. Calculate the probability that the average of the two measurements is within 0.05h of the height of the tower. So we need the probability that the average error is within 0.05h. The error could be, ideally the error is 0. So you could have 0.005h on one side and 0.005h on the other side, where we're calling y to be the average error. So y will be x1 plus x2 by 2, where x1 and x2 are the two individual errors. That's how we get the average of two numbers. Add them and divide by 2. So next thing, we know that since x1 and x2 are normally distributed and they're independent, so their sum is also normal, and so is a constant multiple of a normal variable. So y is also normal, and the mean of y will be half times the mean of x1 plus mean of x2, and we're given that both these means are 0. So the mean of y will be 0. And then the variance of y will be the square of the constant times the variance of the x1 plus variance of x2. That's all known from mathematical statistics. And the variances would be the squares of standard deviations. So we squared the two standard deviations, and this is a fourth. And so we get that. And then we need the standard deviation of the y variable, which would be the square root of variance, which would end up being 0.0356h. So in the exam, you will be given standard normal table. So you have to convert these two values into standard values so that we can use the standard normal table. And we know our basic formula. Z is y minus the mean over standard deviation. Mean is 0, so y minus 0 over the standard deviation for y. And the two extreme values were negative 0.05h and 0.05h. So we substitute them for y to get these two z values. And therefore, in the standard curve, we need the probability that z is between negative 1.4 and positive 1.4. So we need this probability. However, the table that is given to us in the P exam is a table which gives only the values to the left of a z. So let me show you the table that we are given. So we are given this table. And let me make sure that we are having the screen. So stop share. So this is the table we are given. So you see that, for example, on z equals 1.4, we're given that the area to the left of 1.4 is 0.9192. So we're only given areas on the left of positive z values in this table. And somehow we have to manipulate our problem to put it in this kind of a form so that we can use the table. So the left of positive z values, everything needs to be converted to that. So now if we go back to our word screen, we have, no, not this one. Our word screen is, okay, let me find it from here. It's here. So you see that this in-between area is the same as if we get area on all the left of 1.4, which would be from here all the way until the end, left end, minus this white area. So we could have BZ is less than equal to 1.4, which is all the area on the left of 1.4, and minus this one, so minus the area on the left of negative 1.4. So now we still have the issue that we have this negative value and we need everything positive to use the table. And so area on the left of negative 1.4 is this area, which is the same area as the one over here, which actually will be 1 minus the area on the left of 1.4. So this area is the complement of the area on the left of 1.4. So in the next step, I replace this area, the negative z less than equal to negative 1.4 by 1 minus probability z is less than equal to 1.4. And then I already had this one. So then this one and this one add up and get 2 of p z less than equal to 1.4 and then minus 1. And now I can use the table value from the table. Let's go back to the table again. So we have to look at 1.4. So stop sharing this one and share the table screen. So on 1.40, basically we read the probability value to be 0.9192. So we go back. So this value is 0.9192. So 2 times 0.9192 minus 1 equals 0.84, which is choice D.